Unit 7, Ratio and Proportion. Let's start with 7.1, Equivalent Ratios. Orange squash, if you know it, it's a drink that we mix. Comes with like delicious sugary orangey syrup. And so what this question says is we mix it with water in a ratio of 1 to 6. So for every unit of orange squash, we use 6 units of water. And this table gives some examples. So if we had 5 cubic centimeters of orange squash, that's sugary syrup, then we would add 30 cubic centimeters of water. If we had 20 cubic centimeters of that syrup, more orange squash, then we're going to have more water. It's going to be 120 cubic centimeters. And if we only had 1 cubic centimeter of orange squash, well, we would add 6 cubic centimeters of water, and hence the 1 to 6 ratio. So what we can say, or how we can write that, is the orange squash, the ratio, the amount of orange squash to water can be written like this. And so we would use the values, such as here, this one here, the amount of orange squash is 5, so that's 5, colon, amount of water to 30. So that represents 5 parts orange squash, 30 parts water. We could also write this as 20 parts orange squash to 120 parts water. And finally 1 part orange squash to 6 parts water. And this one right here, 1 to 6, is the simplest form. Okay, 1 part is reduced to the number 1, and then the other part is whatever it happens to be, and that makes the ratio. So for us, 1 part orange squash and 6 parts water, that's the simplest form. You could do this with any ratio, and you can bring any ratio down to simplest form. So if we had something like 4 to 10, well, we could reduce this down to find the simplest form. So if we want to make the 4 a 1, well, we would divide that by 4. If we want to make the 10 its lowest form and maintain the ratio, we would divide that by 4 as well. So 4 divided by 4, well, that's 1, right? That's the whole point. What we're doing, this makes it the simplest form because there's a 1, and 10 divided by 4 is 2.5. So 1 to 2.5, that's how you would read this, is equivalent to what we had originally, which was 4 to 10. So these right here are equivalent ratios. So let's do some questions specifically around that. Write each of these ratios in its simplest form. Okay, so A, we're starting with 7 to 14. Okay, so I'll write that out, 7 to 14. And we want to reduce this to the simplest form. So we want to take the 7 and turn it into a 1. And what do we do to that 7? What operation do we use? Well, we divide it by 7. And if we divide the left side by 7, then we divide the right side by 7, just like we do with algebraic equations. 7 divided by 7, well, that's equal to 1. And that's why we did that. And 14 divided by 7, that's 2. So 1 to 2 is an equivalent ratio of 7 to 14, and that's also the simplest form. B is 15 to 25. Let's bring that down to its simplest form. So we want to take the 15 and turn it into 1. So just like with the 7 and up here with the 4, we're going to divide 15 by 15. And if we do it to the left side, we do it to the right side, so we're going to divide 25 by 15 as well. Okay, 15 divided by 15, well, that gives us 1. And 25 divided by 15. Okay, if we use a calculator, we find out that that is actually 1.66666. And we can write that as 1.6 repeating with the dot on top of the 6. And if we wrote that as a fraction, which wouldn't really work here, you could reduce that down to 5 over 3. Let's do C, which is 10 to 4. Very similar to the random example I have up here at the top. So 10 to 4. So what are we going to do? We could reduce the 10 down to a 1, but then obviously the 4 would be less than 1 because we'd be dividing it by 10. So what we usually do is we take the lowest number and bring it down to 1. That way we'll have a value on the other side that's greater than 1. So in that case, what we're going to do here is we're going to divide the 4 by 4 to bring it down to 1, and since we're doing dividing by 4 on the right side, on the left side we're also going to divide by 4. So 10 divided by 4, that's 2.5, and 4 divided by 4 is 1. So 2.5 to 1 is the simplest form of 10 to 4. Alright, in example 2, we want to write these ratios in the form of 1 to n. So we're explicitly being told that 1 will be on the left side and then some value will be on the right side, but we have to keep these ratios equivalent. Okay, so let's do A. 3 to 12. We want 1 on the left side and we want whatever value, maintaining an equivalent ratio on the right side. So we're going to divide 3 by 3, and since we do that to the left side, we're going to divide 12 by 3. That's kind of an ugly 3, but you know what I'm doing. 3 divided by 3 is 1, and 12 divided by 3 is 4. So there's A. B is 5 to 6. So again, we want 1 on the left side, so we're going to divide 5 by 5. We're going to divide 6 by 5 to complete this. 5 divided by 5 is 1, and 6 divided by 5 is 1.2. Had to step over and use the calculator. Alright, now finally let's do C. 10 to 42. This one's a little bit different than the others because there's more digits, but it's still the same process. We want 1 on the left side, so we're going to divide 10 by 10. Since we divided the left side by 10, we're going to divide the right side by 10, and we're left with 1. 42 divided by 10 is 4.2. There we go. Let's do another example with equivalent ratios. So let's say the scale on a map is 1 to 20,000. That's what this means right here, 1 to 20,000. And maps is really where you would come across this quite frequently. So what actual distance does a length of 8 centimeters on the map represent? Okay, so here is the map, right, on the left, and then on the right is real life. What does it represent? That's how this ratio is made. So some value on the map, an equivalent ratio to what it would be in real life. So 1 to 20,000 is what we're given. So that means that 1 centimeter on the map would be 20,000 centimeters in real life. Well, we have 8 centimeters on the map. Okay, we have 8 times that, which means we can multiply 8 by 20,000 to get what it would be in real life. And 8 times 20,000 is 160,000 centimeters. We could leave it like that, but that would be a strange unit to use with such a huge amount of zeros, and so we can convert centimeters to meters. We know there's 100 centimeters in 1 meter, so that means that we're going to move the decimal over 2 spots here. So that means we have 1,600 meters, and we know that there are 1,000 meters in a kilometer, so we would move the decimal over 3 spaces, and we would know that this is equal to 1.6 kilometers. So 8 centimeters on the map is equal to 1.6 kilometers in real life according to this scale here, which is 1 to 20,000.